Hi, in this tutorial I would like to give you an overview and basic understanding of statistical terms that you will constantly meet on your statistical journey. You will always deal with statistical testing. Before you test something, you must know what you are going to test. And in statistics, the thing you are testing is called hypothesis. Hypothesis is always a prediction from a theory. In order to test the hypothesis, we need to measure variables. Variables are things that can change or vary. They might vary between people, such as, for example, IQ, or locations, such as, for example, unemployment rate, or even time, for instance, mood or profit, last year, this year, and so on. Most hypotheses can be expressed in terms of two variables, a proposed cause and a proposed outcome. And based on these we can distinguish between independent and dependent variable. A variable that we think is a cause is known as an independent variable because its value does not depend on any other variables, and the variable that we think is an effect is called a dependent variable because the value of this variable depends on the cause, so on the independent variable. Sometimes you can also use terms predictive variable and outcome variable in place of dependent and independent variable. These terms are usually used in experimental work where the cause, independent variable, is a predictor and the effect, so the dependent variable, is an outcome. Now we will have a look on levels of measurement of variables. The relationship between what is being measured and the numbers that represent what is being measured is known as the level of measurement. It sounds really scary, but no worries, it is not as complicated as it sounds. Broadly speaking, variables can be categorical or continuous and can have different levels of measurement. A categorical variable is, not surprisingly, made up of categories, and the categorical variable, for example, is gender. You are a male or a female, but you cannot be both. A categorical variable is one that names distinct entities. In its simplest form, it names just two distinct types of things, such as in our example, male or female, and this is known as a binary variable. Other examples of binary variables are being alive or dead, pregnant or not, or responding yes or no to a question. In all cases, there are just two categories, and an entity can be placed only into one of the two categories. Furthermore, we have two types of categorical variables, nominal and ordinal. In nominal measurement, the numerical values just name the attribute uniquely. Numbers only serve as labels for identification and categorization, and they do not reflect the amount of the characteristic possessed by the objects. For example, we have a football player with number 30 and we have a football player with number 15. A player with number 30 is not more of anything than a player with number 15 and is certainly not twice whatever number 15 is. The only way that nominal data can be used is counting or frequencies. For example, we could look at how frequently a player with number 30 scores compared to the number 15. Another example of a nominal variable can be starting numbers in a race. The nominal categorical variables we have considered so far are unordered, but they can be ordered too. For example, levels of education. We would have, for example, categories high school, bachelor degree, master degree, or higher education. What does it mean that they are ordered? Well, we can say which one is higher and which one is lower. We call this variable an ordinal variable. Ordinal data tell us also the order in which they occurred. However, they tell us nothing about the differences between values. To understand this better, let's have a look at another example of ordinal variable. Do you know the X Factor show? The X Factor is a TV show broadcast across the globe in which singers compete to win a recording contract. Imagine that 3 winners of a particular X-Factor series were Billy, Freema, and Elizabeth. The names of the winners don't provide any information about where they came in the contest. However, labeling them according to their performance does. So we know that Billy was first, Freema second, and Elizabeth third. These categories are ordered. In using ordered categories, we now know that the woman who won was better than the woman who came second and third. We still know nothing about the differences between categories, though. We don't know how much better the winner was than the runners-up. Billy might have been an easy victor, getting many more votes than Freema and Elizabeth, or it might also have been a very close contest that she won by only a single vote. Ordinal data, and this is the important thing I would like to tell you, tell us more than nominal data because they tell us the order in which things happened, but they still do not tell us about the differences between points on a scale. So just a quick summary. The first level of measurement are categorical variables, which can be either nominal or ordinal. Okay, the next level of measurement moves us into continuous variables. Continuous variable is one that gives us a score for each person and can take on any value on the measurement scale that we are using. We have 2 types of continuous variables, which is interval and ratio. The first type of continuous variable that you might encounter is the interval variable. Interval data are considerably more useful than ordinal data. To say that data are interval, we must be certain that equal intervals on the scale represent equal differences in the property being measured. For example, if students rate their lecturers on several dimensions, such as for example helpfulness or clarity, and each dimension is evaluated using a 5-point scale, for this scale to be interval, it must be the case that the difference between ratings of 1 and 2 is the same as the difference between, let's say, 3 and 4 or 4 and 5. Similarly, the difference between ratings of 1 and 3 should be identical to the difference between ratings of 3 and 5. The second type of continuous variable is a ratio variable. In addition to the requirements of an interval variable, the ratios of values along the scale should be meaningful. And what does this mean? Well, it means that the scale must have a true and meaningful 0 point. The time to finish a race is a good example of a ratio variable. Let's say you finished a race in 30 seconds, I finished it in 60 seconds, and your statistics professor in 90 seconds. When we measure time, we can say the difference between 30 and 60 seconds is the same as between 60 and 90 seconds. Also, the ratios of values along the scale are meaningful. In our example, we can say that you were twice as fast as me. So, to summarize the levels of measurement, we can split variables into categorical and continuous. Categorical variables where entities are divided into distinct categories can be binary, nominal, or ordinal, and continuous variables where entities get a distinct score can be interval or ratio. Hopefully this gave you a good overview. Please make sure to understand the differences between the variables, as you will need this very often once you start conducting tests. Thank you very much for your attention.